For our next example, we still have a rational expression plus a rational expression. When we add, we need a common denominator. Since we have the same common denominator, we keep it. We add the numerators. A binomial plus a constant, we have an x. Negative 5 plus 2 is minus 3. Now this would be complete except that we need to simplify. Our denominator will factor difference of squares, x plus 3, x minus 3, which notice then, just like we had before, the x minus 3 and the x minus 3 will cancel. Right? This is how we reduced our rational expressions. Our numerator, that coefficient that was left, is that 1 over x plus 3. Always make sure to reduce on these. Our next example, 3x over x plus 2 minus x minus 5 over x plus 2. Now, when we have a common denominator, I'm going to show down here, it's common, so we're going to keep that same common denominator. But at the same time, when we look at subtracting the numerators, just like when we subtracted polynomials, what we're going to have is 3x minus x minus 5. But remember what we did when we had to subtract polynomials was we distributed the negative. We had to change all those signs. We even looked at it at one time like it was a negative 1 that I'm distributing. We'll distribute that negative 1 across, and what we end up with is 3x minus x plus 5. It's easy to notice the minus in front of the x. It's easy to forget changing the sign of every term in there, particularly that 5 in this case. So what our numerator ends up being is 3x minus x plus 5. When I combine some like terms, I get a 2x plus 5 over x plus 2. One more example problem. If I have x squared over x minus 4 minus x plus 12 over x minus 4. Same as last problem, it should just try to force it into a habit of always just distribute that negative across. X squared minus x minus 12 in this case. Remember that it's just changing those signs. That's what's going on here when you subtract polynomials and when you distribute that negative 1. Now again, we would be done, except that we always have to look to see if it reduces. Factor the numerator. As much as we want to say two negatives are two negatives, remember, when we see that negative 12, it means different signs. When we see that negative x, it means there's going to be the sign of my bigger number. In this case, factors of 12 minus 4 plus 3. Because again, big picture, 3 times negative 4 is negative 12. 3 plus negative 4, negative 1. There's my numerator factor. And now look, my denominator, my x minus 4's cancel. I'm left with just an x plus 3. Now, up here, when we had the x plus 3, remember we had the 1 in the numerator because it was the denominator that x plus 3 sat in. Down here, it just happens to be the numerator. We could put that over 1, but it would still be not simplified in the fact that just like if we had a 1x or an x to the first power, we want to leave things in as simple form as possible, and we wouldn't want to put divided by 1 because divided by 1 is itself.